looks like. So now we will talk about data analysis primarily. For example, fraudsters usually target, the first one we have is a bar graph, which is fraud distribution by transaction type. So we can see that the fraud markers is 92. Distribution of transaction amount. Scatter plot basically shows, so this is how it looks. In this graph, we can basically see, I can pick up the top 3 states or top 5 states, and in certain states, what can happen is, hi everyone, welcome back to my channel. My name is Anuj and you're watching Analytical Anuj, and this is the second part of the most awaited video for UPI fraud detection project using machine learning. And I want to start by saying thank you so much for all of you for the incredible response that I have received on the first video. I had not expected such a response from anyone, especially in such a short amount of time. But thank you so much for liking the content that I'm trying to make. And in case you have not watched the first part of this video already, so I recommend please watch that video first, because we are going to start this project from where we left off in the last video. We had covered most important topics of Pandas. How do we import, uh, the project? How do we start working on it? How do we analyze? And some important functions of Pandas. We also have covered many important questions which are asked in the interviews. So if you have not watched that video already, please go ahead and check that out first. And please do watch this video till the end, because I'm going to tell you the most important things to keep in mind in case you're trying to build this project on your own. Some people were asking me to share the dataset for this project. Unfortunately, the dataset is not open source, and therefore I could not share it with all of you. But yes, you can find many sample datasets on Kaggle, which you can definitely use for yourself. And I will tell you the changes that you will have to make in the project. But you can more or less follow the same approach that I'm going to follow, and I'm going to show you how this project is going to be laid out from the starting till the end. And without any further ado, I'm going to show you the agenda for this video. So let me just pull up the agenda for the video. So in the previous part, we have already covered how do we import libraries, the data importing and data preparation part. How do we check and analyze the data? What changes or modifications we make to the data before we start building our models? So we had done, I guess, till this part. Okay, this was the only part that has been covered. And now we are going to start with the next part of the video. Let's get started, and hopefully we'll try and upload more frequently. Get started with it. In case you have not downloaded the essential libraries that I had recommended in the past, so please do check that out. I have uploaded all the videos on my channel already, and hopefully you should be able to follow along. I'll try and share any sample data set that can be used for this project. If I can find so, I'll definitely share that in the comment section. So let's get started with it. So in the previous video, we had created two different data sets. So as you can see in the previous video, we had seen the visualization and the distribution of the target variable, and that is approximately 1.5%, 1.5% of the overall data set, which is very less. And therefore, we are going to proceed and analyze what all transactions or what all attributes are contributing towards fraud. So the normal transactions that are this 98%, close to 98%. So we do not want to understand what transactions are non-fraud. We are trying to understand what particular attributes can contribute towards fraud. So what I need to do is basically I need to check this part only, because this is in question. So what we are going to do is we are going to take two separate data sets now. One which is non-fraud transactions, one that is only fraud transactions. Then we are going to analyze the fraud transactions and build upon it. So I'll explain this to you. Starting with off. So first off, what I want to do is I want to create separate data sets for normal and fraud transactions. So to create normal and fraud transactions, so this is something that we are going to do with the help of pandas. So we have to define a condition first. So for example, if you see we have so many columns available, so the target variable is this fraud column, right? So now what we are going to do is we will say df of fraud equals to 1. So wherever it is 1, this is basically fraud. So we can say, let's suppose this is the condition, to take it as, okay, so this will be fraud. fraud only. And if I run this, now this is a separate data set. And if I show you the first three rows, it will have the same columns and everything, but in the end, you will see that this is only showing up that fraud transactions. And if I want to see how many rows do I have, so for example, I can see that there are 774 rows with 16 columns. And if I could show you df dot shape, so I had 16 columns. So even in fraud data set, if I take the snippet of only fraud data, the columns will be same, but the number of rows will be 774, which is close to what we had when we went to fraud transactions. So if you see, okay, so close to 1.5% data is this. Okay, so what if I df dot fraud value counts? If I show you df dot fraud value counts, and, that's it. So you will see that the number of fraud transactions is how much? 774, which is exactly what we have. So we can see that the condition that we have defined for filtering the data. So we can say filtering or extracting fraudulent transactions only. Okay. So this is what we have done. And similarly, we will create a normal data set. So extracting normal transactions from the entire data set. So how do we do? df, and in this one you define fraud and the condition is 0. Okay, so this has been created, but this is not assigned. So I want to assign it to a new data frame, call it as normal. And now if I say normal dot shape, it should be close to 49,226. And if I take you back where we did the distribution, we can see that 49,226 transactions are non-fraud. And so we have exact filtration done. So we can see that the two data sets have now been separated. Now that this has been done, we can analyze the fraud data set. Analysis, analyzing the fraud data set. Okay, we're going to start with this one. So let's suppose I will say df.head. I can see the top 5 rows here. So I can see all the columns here. At the date column, I have the date column, day since last transaction, year and month. I want to delete the date column. The date column is not required because I've already taken the month and the year part. So date is particularly not important for me. So I want to delete it. So fraud dot drop. Now the column that I wanted to delete is date and place equals to this equals to 1. Now if you see this data set does not have the date column, which is fine. And now we want to see the data types. We want to check data types. So fraud dot d types. If you see, so we have mostly the categorical variables. We have numerical variables, but only 1, 2, 3, 4, 5, and 6. We have partial variables, which are numerical. We have some variables which are categorical. So we'll accordingly see what we can do. And let's change it properly. All right, guys. So now that we have drawn this correlation metric that you can see, this is called correlation. Now, correlation basically means, so what is the relationship between the two variables, which are the independent variables. So for example, if I can say, if you want to know what is correlation, you can learn about uh, correlation. There are different types of correlations I can show you. So basically, we most of the time use Pearson's correlation. So when it comes to correlation analysis, it really helps us identify what features are important and what features are not important. So this is one of the ways. So you can see, you can read about this. Uh, okay. So there are different types of indicators. So basically what we are trying to learn is, when it comes to correlation, the different types of independent variables or the features which are used in the machine learning models, they can either be positively correlated, negatively correlated, or non-correlated. So for example, let's suppose we talk about the salary of an individual. So when it comes to salary of an individual, when we compare it with the number of years of experience, right, As the number of years of experience increases, the salary tends to increase. So these two variables are directly proportional to each other, which means when one of the variable increases, the other variable also increases. So this type of relationship is called as positive correlation, as you can see here. Okay, so this is called positive correlation. Positive means when one of the variable increases, the second one also increases. The second type, as you can see, is called zero correlation. So for example, I could say the uh, how the education basically helps you to get more salary. So if you see in today's day and age, there is no strong correlation between your qualification and your earnings, because a person who might not have the level of qualification as yours might be earning a lot compared to you. So especially in today's day and age, education is not a primary factor of defining how you will be earning in the market, because there are different ways to make money now, irrespective of before. Just one of the examples you can get the idea. When we talk about negative correlation, however, it can be that when one of the variable increases, the other one decreases. So for example, I could say, as the temperature decreases, the sales of ice creams also decrease. Okay, so basically, like in winters, people don't buy what people do not buy. Cut this out. Now when it comes to negative correlation, so you can imagine like one of the variable increases and the other one decreases at the same time. So for example, you could say when temperature increases, right, so the sale of winter clothes basically decreases, or something of that sort, right, because these are not relevant to each other. So it can be non negative correlation. So what we basically want is that two of the variables that are positively correlated, that means that they can be impacting my analysis. So this is the idea. So you can read more about this one here. That is, what is positive correlation, what is negative correlation, what is zero correlation. Now when it comes to a positive correlation, they say that it indicates that two variables move in the same direction, while a negative correlation indicates that the two variables move in the opposite direction. The strength of the correlation is measured by the correlation coefficient, which can range from -1 to +1. Now this is important. So as you can see in the code as well, if I show you the code, in the code also you can see that the range between the range of this correlation coefficient ranges from +1 to -1, and that is it. That's the range of it. It cannot be more than 1, or it cannot be less than -1. A correlation coefficient of 0 indicates that there is no correlation, while a correlation coefficient of +1 or -1 indicates that there is a perfect correlation. Okay, now this is a table that they have defined. You can definitely understand this one. So we have Pearson's correlation coefficient, which shows linear relationship. It can be like normal distribution. Then we have Spearman rank correlation coefficient, and this can have like non-linear correlation. We'll talk about this ordinal and non-ordinal variables or nominal variables. So we'll talk about this one. These are the different types of correlation that we can use. So you can read about this in more details. Okay, I'll come back to my code and let you know. So basically, in this particular correlation table, none of the variables are showing any strong correlation with the other variables. Now when it comes to correlation, one thing that I would like to tell you is that if two variables are highly correlated with each other, that is, for example, if their score is more than 0.8 or something, in that case it might also result in something called multicollinearity. Now multicollinearity is one of the biggest challenges that we face basically when it comes to model building. It means that two features present in the model, they kind of act like the duplicate of one another. For example, if I have two different variables in my model building, even if I drop one of them, the model will behave exactly the same way, which means I have redundant features in my model, which is not very optimized. So multicollinearity is not a good thing, and that basically means when multiple independent variables showing high, you can say high correlation. Okay, so you can study about that also. In this particular analysis of mine, none of the variables are highly correlated. However, there is a moderate positive relationship between transaction amount and fraud. So if you see transaction amount and fraud, Alright guys, so now I'm going to show you how the visualization of the entire dataset looks like. So now we will talk about data analysis primarily. So I've already written the code. Okay, so I'm just going to show you this one. The first graph that I've just driven is this pair plot. Now pair plot basically means that we are going to find a relationship between every two variables and try to visualize and see if there is any relationship here. So I've defined my data set as the entire data, which is df. I want to try and see the two differences like fraud and non-fraud. So I define my target variable as hue. My color palette is pastel, and you can choose distribution as of your choice. For example, I've given dist. Okay, so it is showing me the distribution like this. So when you run this one, it shows you the relationship of two variables. For example, blue means it's non-fraud and orange means it's fraud. As you can see, the orange ones, you can see the days since last transaction and the transaction amount deviation, how the ranges or how these two variables are related to each other. For example, I can say amount and transaction frequency. So when it comes to fraud, which is orange, as the amount increases, which is more than 2000, the amount of fraud is very high, as you can see. Okay, and from 0 to 2000 also you have certain orange dots, which means that they have contributed to fraud, but more than 2000, most of the amount is fraud. Certainly we have got your transaction amount deviation. Now transaction amount deviation and the amount, we can see that when the amount or the deviation is more, right, so the number of fraud also increases when the deviation is quite high and the amount is high. And you can see the relationship of all these variables. You can scan for yourself. Okay, and then what I've used is I've used the fraud variable, a fraud data set. Now I have used Plotly Express. Now Plotly Express is widely used data visualization, you can say, library that has variety of features. So the primary reason why am I using Plotly Express is because it adds dynamic nature to it. So I'll show you in a minute. I've drawn like 8 visuals. So mostly I've used bar charts. It's very simple. You can define your X variable, your Y variable, the color palette that you want to choose. You can define your title, the labels, and you can define your color pastel and the layout, right? I have sorted all these variables in the descending order so that it's easy for us to see. You will see that. So I've given the distribution of fraud by transaction type. I want to see if there is a relationship between payment gateway and fraud, any relationship between merchant category and fraud, any relationship between transaction amount and fraud. And I've seen the relationship between transaction amount frequency and scatter plot and the fraud using scatter plot. So let's see these graphs one by one to understand the differences. Okay, the first one we have is a bar graph, which is fraud distribution by transaction type. Now this is already sorted in you can say descending order. So the left one is the highest, you can say, contribution towards fraud. So now what you say is the fraud distribution by transaction type. On the right hand side you have got the labels. So we can see that it's very colorful, and you can see that as I take my cursor to these bars, I can see the exact number. So when you use Seaborn or the libraries, right, you can definitely draw bar graphs, but you might not be able to see the exact number, which might make it a little challenging. But in this case, what happens is you can see the exact number of fraudulent markers. So when it comes to the type of transaction, we can say bank transfers are highly prone to fraudulent transactions. Purchases, when people are making purchases online, it is highly prone to fraud. When people are trying to make any investment into mutual funds or using their credit cards or something, that can be prone to fraud, like buying gold or something online. So these three, I would say, are highly susceptible to fraud, at least as per this visual. So my top 3 picks will be these 3. So whenever any kind of purchases falls into these kind of transaction types, maybe we want to pay more attention to them. Okay, and when it comes to the second visual, it's also a bar graph. Now this bar graph is a payment gateway. So payment gateway is a platform that allows you to process your payment. Now payment gateway allows us to process the payment. Now for example, it can be like Google Pay, it can be Phone Pay, or the different applications that allow you to run your UPI application to make a payment. So these are payment gateways. So in this graph, we have tried to understand whether there is a certain platform and that is contributing towards fraud. Okay, maybe we want to look at some technicalities and find some vulnerabilities in that platform. So these are all dummy data, as you can see. So Alpha Bank, for example, they have the highest number of fraud, 103. Fusion Pay, then we have Vertex Bank. So these will be my top 3 picks which are contributing to fraud when it comes to payment gateway. Now similarly, we have merchant category. Now when it comes to merchant category, the type of merchant that we are spending or making the transaction for, this is what we are trying to know. So for example, I can say when it comes to home delivery, like it can be for you can say couriers or online shopping like eCart or Amazon, or it can be Swiggy or Zomato, or any kind of platform that allows you to have the food items delivered, or it can be any platform that delivers something to your doorstep. Okay, so we can see that the fraud markers is 92. Okay, so this category is contributing towards the highest number of fraud in this visual. Then we have travel bookings. Now when it comes to travel bookings, it's important to note that most of the travel bookings usually happen in advance. So people plan for their vacation well in advance, which means that I'm paying for a service or I'm paying for an airline ticket maybe 6 months ago or 3 months ago or 4 months ago. So the chances of having that kind of fraud later on is quite high when it comes to traveling. So for traveling agencies or travel bookings, it might happen at times. So this is 90 markers for fraud. Utilities, we have 82, so we can pick accordingly. And then we have a distribution plot. Now this is a distribution. A distribution can be discrete or continuous. This one is a discrete. As you can see, it shows fixed numbers. It can also be like a kernel distribution, so a density plot if it's absolutely continuous, but this one is discrete. What am I trying to see when it comes to this graph? So I'm seeing distribution of transaction amount. Okay, so I can see when it comes to the amount of 250 to 750, the potential of the transaction being fraud is quite high. So there are 362 transactions reported as fraud when the amount was between 250 to 750. Okay, so this range is highly susceptible to fraud. When it comes to 750 to 1250, the number is less, but yes, this is also active. And then as the range increases, we still have some amount which is contributing to fraud. So this will be my highly active range when it comes to fraudulent transactions. Next, we have a scatter plot, which is showing us the relationship between the transaction frequency and fraud. Scatter plot basically shows a relationship between two numerical variables. In this graph, we can basically see when the transaction frequency is 0 to 10. Between 0 to 10, we can see that the number of fraud markers is kind of same. So it's not contributing as much. But as the transaction frequency increases, like 20, 30 transactions a day, 40 transactions a day, or even 50 transactions a day, when that frequency increases, the amount of fraud also increases, which is a generic pattern of fraudulent transactions. That is when people have they are committing fraud, they tend to make smaller transactions but more frequent transactions. Okay, that's the generic pattern that we have seen. That's the more generic pattern that we have seen. Next we have is a scatter plot that shows the relationship between days since last transaction and fraud. Now in this one you can see this is more or less constant. Now whether there is a gap between the transactions, like 0 days, 1 day or 2 days of gap, 3 days of gap, 5 days of gap, the chances of that transaction being a fraud is almost same. So as you can see, there is no variation in this graph. No matter the range, the chances of being fraud is same. So when there is no variation, it's not contributing much to our analysis. So I'm going to drop this column. Okay, so this is one analysis for me. Next, in terms of geographical analysis, I'm going to say fraud distribution by transaction state. So I can say in this graph, Himachal Pradesh has contributed towards the highest number of financial frauds, 41 in this case. Although this is dummy data, so this is not real, but just to show you some practical implementation and understanding, I'm going to show you this. So this is how it looks understandingly, and I can pick up the top 3 states or top 5 states, which mean maybe we want to look at what exactly is happening in those states when it comes to those transactions. Are there any certain factors which are contributing towards these UPI transactions being fraud? Okay, so we might want to look at that. And in certain states what can happen is the literacy rate is also different. So for example, fraudsters usually target audiences that are not highly literate or aware. They will try and find different ways of committing fraud, and that is why it's important that sometimes they pick people who are not highly educated, or they are not highly aware of what's happening, so they might want to trick them very easily and commit fraud. So this also might be because of literacy factor or awareness factor. So people who are living in tier 1 cities, okay, they are usually aware of most of the things happening, and that's why it is difficult comparatively when it comes to committing a financial fraud in a village area or a rural area wherein people are not very versed with the technology part. So that's the harsh reality, and these scammers or fraudsters definitely take advantage of those situations. Next, we have fraud distribution by device operating system. So we can see that when it comes to UPI transactions, it can be made using Android, it can be used using Windows or iOS or macOS also, because you just don't always have to scan a QR code. You can also enter the UPI ID. Okay, so every UPI address is also one of the ways to make a payment. So you can definitely make a payment using your Windows laptop or macOS. Okay, so it shows that the Android devices, being very common, they are the highest contributors towards fraudulent transactions when it comes to UPI. So most of the frauds that happen, it happens because of Android, but again, this is dummy data. Okay. Then we have this Windows and iOS and macOS. So this shows the data. I hope you got some idea with this analysis. Okay. And now what we have to do is, I am giving you a task. Show me or write to me the inferences. Inferences is what can you write or what can you suggest these businesses or these banks or payment gateways or these merchants that maybe you want to implement this. So whatever is your analysis using these graphs that I've just shown you, you might want to just make a list of it and write it down in the comment section, so I can see if you have got more idea about this analysis and what would you recommend these providers so that they can improve their security and prevent fraud. Okay, so I look forward to it. Implement this one.